Welcome to question 5 of the 2021 Mathematical Methods Exam 1 for the Northern Hemisphere. In this video, we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. For question 5, part of the graph of f, which has a domain from negative infinity to negative 1 not included, union with 2 to infinity, both not included, with a rule of f of x equals negative 2 sine of pi x plus 1 is shown below. We then let G have a domain of negative 1 to 2 and a rule of negative 2 sine of pi x plus 1, so the same rule as F but a different domain. And part A asks us to sketch the graph of G on the axes provided above for 1 mark. So for 1 mark we need to sketch the graph, so we'll need to make sure that the shape of the graph is correct and that the key features are in the right spots and that we use the correct endpoints. But because it hasn't asked for us to label maximums or minimums or x-intercepts, we won't need to do that at this stage. So the graph of G has essentially the same shape as F, and we're just trying to fill in the part of the graph that's missing on that grid. Each half of the graph goes 1 unit across and 2 units up to its maximum. So if I start at negative 1 and identify that we're going to have a maximum up here at 3, before it returns to the y-intercept at 1, then it will go down as far as negative 1 here, and back up to 1, then it will go up to 3 around here, and then back to where the next part of the graph kicks off that's already drawn. We can see that there's square brackets for the domain of G, so we need coloured in dots at negative 1 and 2. So with all that in mind, coloured in dot here, and then the graph will have this shape, and it will finish with a coloured in dot at 2. So that's all we need to do for part A of this question. And the examiner's report notes that the endpoints are included, so that was vital for getting the correct mark for this question, and there a computer generated version of the graph is shown, which is what we just drew. So while still considering the same function g, we want to find the solutions to g of x equals 0. So g of x equals 0 is the same as negative 2 sine of pi x plus 1 equals 0. So subtracting 1 and dividing by negative 2, we're essentially just solving the equation sine of pi x is equal to positive 1/2. Now we can bring up a unit circle, or you could quickly sketch one in an exam, and identify that sine of a half occurs here in the unit circle. So going out to the points on the unit circle that have that y value, we're going to have a spot here and a spot here. And connecting them to the origin, we can identify that we need the exact value of pi on 6 here. And for our second one, we need to go all the way around to here, which is 6 pi on 6 minus pi on 6. So that will be 5 pi on 6. So coming back to our working, we're going to say that pi times x must equal, and it's going to be pi on 6 or 5 pi on 6. If I actually go back to the graph that we sketched, solving g of x equals 0 is really just asking us to find the x-intercepts of this graph. So we know there's only 2 of them, and we know they're the first 2 positive solutions. So that's why I'm only really considering pi on 6 and 5 pi on 6, as they are the first 2 angles in the positive direction that give this equation equal to 0. We can then divide both sides by pi or multiply by 1 on pi to get x by itself. And we are going to find that x is equal to 1 on 6 or 5 on 6 are the 2 possible solutions. So they are the answers for part B of this question. And as I said before, they actually form the x-intercepts of that graph. From the examiner's report, we can see that we got the same answers as they did. Part C asks us to find the area of the region bounded by the graph of G and the x-axes. So if I bring up a graph of g of x, and I've just used a computer-generated one to put on this slide, but you could refer back to your answer from part A, the area in question is fully bounded by G and the x-axes. So that means that it's this area just in here, and I've actually put the coordinates of the x-intercepts on the graph that we found in part B on this graph to make it a bit easier to follow along. So we're going from 1 on 6 to 5 on 6. So we're finding the area between the x-axis and the graph between 1 on 6 and 5 on 6. So that area is going to equal the integral, And because the area is below the x-axis, we need to account for that. So to do that, I'm actually going to swap the terminals in this example. So we're actually going to go from 5 on 6 to 1 on 6 of the function g of x, which is minus 2 sine of pi x plus 1, and that's with respect to x. Calculate that, we're going to find the antiderivative of minus 2 sine of pi x plus 1. And looking at your formula sheet, you'll see that sine actually goes to negative cos. With an extra negative there, it will be positive by the time we calculate our antiderivative expression. So it's just going to be 2 on pi times cos of pi x. And then the plus 1 just becomes plus x when anti-derived. And we're still going between 5 on 6 and 1 on 6. And again, we've swapped the terminals because that area is below the x-axis. To evaluate that, we now substitute in the upper terminal and then subtract away the lower terminal substituted in. So we're going to have 2 on pi times cos of, and then it's going to be pi times 1 on 6, which is pi on 6. And then it's plus x, which is plus 1 on 6. And then we subtract away the antiderivative with 5 on 6 substituted in. So that's going to be 2 on pi times cos of pi times 5 on 6, which is 5 pi on 6 plus 5 on 6. Now we know that cos of pi on 6 is actually going to be root 3 on 2, and that cos of 5 pi on 6 is negative root 3 on 2. So calculating this out, we're going to have 2 on pi times root 3 on 2. So the 2 on the top line and the bottom line will cancel, and we'll just get root 3 on pi, and then we'll still have plus 1 on 6. And then we're going to subtract away, and I'll still leave the brackets on this so I don't lose track of that negative sign. It's going to be negative root 3 on pi, because again, 2 on pi times negative root 3 on 2, the 2's would cancel. And then we still have the plus 5 on 6 in that bracket. So this is actually going to be root 3 on pi, subtract negative root 3 on pi, actually gives positive, so it's going to combine to give 2 root 3 on pi. And then we're going to have 1 on 6 take 5 on 6, which is actually negative 4 on 6, which is negative 2 on 3. That's an area, so I can say that that's units squared, and that is going to be the answer for part C of this question. From the examiner's report, we can just identify that we got the same answer as they did.